Hi everyone, I'm Dhanuman, and in today's session we're going to take a look into 1588v2 SMPTE media profile. Typically the session is divided into two halves. In the first half we are going to get into more technical details, how SMPTE profile evolved, what exactly it does, what are the configurations, so on and so forth. And in the next half we are going to have a more hands-on where I'm going to show you how you can configure SMPTE profile using IxNetwork. So let's take a look. Typically, SMPT stands for Society of Motion Picture and Television Engineers, and SMPT ST259-2 is a PTP profile primarily targeted for video applications. This profile is applicable on top of ordinary clock, irrespective of master or slave rules, boundary transparent clocks as well. The transport medium selected here is mostly UDP over IPv4 and UDP over IPv6. The typical messages supported on top of SMPT profile are the same which are used in native PTP profiles like sync, follow-up, delay request, PDelay request response, so on and so forth. Apart from that, there is also provision of management message exchanges, which is also included in SMPT. A typical management node communicates with ordinary clocks, boundary clocks, as well as transparent clocks. A management node may either configure or monitor these clocks from a centralized location using PTP management messages. So mostly a monitoring role for the management node. Okay. In IxNetwork, the SMPT profile comes with a communication mode, which is a mix of multicast and unicast. And these are the required and the permitted message transmit modes for various other message types. Like the required message transport modes for announce sync follow-up is multicast. Permitted modes for announcing follow-up is unicast. Delay request messages can be multicast or unicast. Delay request messages can be multicast or unicast, so on and so forth. SMPT also tells the user from its specification that the timing accuracy for the slave to lock in with a grandmaster or master needs to be within a vicinity of 1 microsecond. And typically the time required by the slave to synchronize and perform this task needs to be within a vicinity of 5 seconds. So this is again coming directly from the spec. Now let's take a look into what all are the configurables and how SMPT profile typically looks on top of IxNetwork. As you already know, IxNetwork provides a plethora of profiles on top of its 1588v2 emulation. SMPT ST2059-2 profile is another addition to that list. So typically when you click the profile drop down, you see a new addition to the list which can be used for configuring SMPTE. The default modes for management messages as well as other messages and the default values gets already selected when a user typically selects SMPT ST259-2 profile. The typical configurables for management messages are all exposed to the user. All the fields which take part in the management message exchanges can be altered or can be changed as per requirement using the SMPT tab, which includes all the options. So I will get into this in more details when we go into the hands-on section. Apart from that, SMPT also is integrated with the offset-based trigger logging mechanism, which is a debug mechanism which is integrated now with PTP. With the help of this offset-based trigger mechanism, if a user wants to debug that at any point of time, if its master starts sending erroneous messages which makes a IXIA emulated slave record in different offsets, then a user can choose to provide triggers where the offset message exchanges like the sync and follow-up exchanges would be recorded for further reference. So I will get into this in more details when I get into the hands-on. So let's now take a look into it. I have already created a PTP session, but before going into the run, let me show you how you can see this entire thing working or how you can add that. So typically if you want to add it, you go here, you just press this plus button. Okay. Out here I have already added it, so I will just add an offline port. Let me make the count as 1. And let me show you, if I go to here, if I now want to add it, I go to append ports, I click on next, and over here you just need to type SMPTE, and yes, you can select SMPTE profile from here. So this is easily accessible from here, or you can add a native PTP node and make it change into SMPTE. So it's your wish. Once you do that and you create this topology, you can assign roles to each of the PTP stacks and make it a SMPTE master. So the profile selected here is SMPTE, as I've already told, and this is the profile list where this SMPTE ST 2059-2 has been added. This is the role which has been assigned to this stack as master, and this one is slave. Now when I go to the SMPTE tab, this has been newly added here. You see all the configurables that you can change, which takes part into management message exchanges. Typically these are log management message intervals, default system, frame rate, numerators, denominators. So all the applicable fields are here. So I'm not going to explain this here because it will be time consuming. If you want to refer this, you can go to the user guide, so which I've kept open as a reference, and you can see what all these tabs do and what all the configurations do and which are the allowed values for each of the fields which you can configure. So you can just open the IxNetwork help guide, you can type SMPTE and you see this list of values, and you can directly refer to the spec or this help guide and take further reference from them. Now let's start the topology and see what all are available. Okay. So typically when my sessions are up and running, I will go to the stat section. So I will go to the PTP drill down. I will just start refreshing it. In the PTP drill down section, some new message exchanges have been specifically added for SMPTE, and also you get to see them from the PTP purport as well. So if we go to the PTP purport, apart from the already pre-existing statistics, I also get to see the management messages sent, management messages received. So these all are few additional statistics which gives us a fair view of what all management messages were sent and received. PTP drill down still lets us know the offset, the mean path delay, the T1 and T2, T3, T4. So all the messages that have been exchanged on a rate basis. The same thing is also true for management messages. So as I've given the rate as 1, which is 1 per second, I see this as 1. Okay. So these are few additional statistics which has been added for SMPTE. Apart from that, all the legacy statistics holds true. Now, apart from this, another additional stuff that has been added here is the support for management TLVs. So if you do a typical capture and you open this using Wireshark, so this is the Wireshark which comes as part of IxNetwork. And if you open any management messages that has been exchanged, you can see that the complete SMPTE TLV decoding is also provided here. So this is the SMPTE data. And you see whatever management messages have been configured and the fields that has been configured with specific values are mentioned here. So you can start tweaking the management messages from the master side, and you can do a capture of the slave to see that all your changes are taking effect. So this is another way of validating whether the SMPTE stuff is working fine or not in the device itself. Okay. So now let's go back quickly and see another small feature which we have also integrated with SMPTE, which is the debuggability feature. Okay. So this is the offset based debuggability which we were referring to in the earlier section. So all you need to do is you need to enable this offset based trigger, and you need to provide a threshold value. Say I provide a threshold value in nanoseconds as 200, and I provide how many numbers of records you need to log and a log file location. What happens is, whenever the IXIA emulated slave finds that an offset has been reached which is beyond 200 nanoseconds, it starts logging all the incoming messages or records like the sync, the follow-up messages, the timestamps received from them, the T1, T2, T3, T4 timestamps, and it dumps it into a file. If you open that file, a user can easily trace when exactly this happened, because this is offset based triggered logging, and from the information the user can get to know that what was the timestamp that the message was received at. Based on that, a user can take a definitive action and go back to the device and do their debugging. The rest are already self-explanatory.